So questions related to atomic physics, MCQs. Scattering of alpha particle by a thin metal foil support the nuclear model of an atom. Why are alpha particles used rather than neutron? So why we don't use neutron? Why specifically we use alpha particle? Because they always travel more slowly. That is not the reason. Alpha particles are basically charged particles. So when the charged particles are there in a nuclear model, to identify whether if neutron was used, then neutron does not experience any attraction or repulsion. So it will either collide or it will be stopped, or it will pass straight. But because alpha particle is used, what is the advantage of using an alpha particle, a helium nuclei? Then like charged particle, like charges or unlike charges, they attract or repel. So we should use a charged particles here. Because they are heavy, that's not the reason why we use them. They are large in diameter, that is not the reason. The correct answer is because they are positively charged, they are charged particles. That's why we prefer to use alpha particle in the nuclear model, not a neutron. Then the nucleus of radioactive substance undergo an alpha decay and followed by beta. Look, if we have alpha decay, like element polonium is there, which is 218 and 84. So first it undergo alpha decay. If undergo alpha decay, what happened? Due to alpha decay, atomic mass decreases by 4, like it will turn into a new element X example. Atomic mass decrease by 4 and atomic number decreases by 2. So it will become 218 and there will be an alpha particle. And then they mentioned the new nucleus which is formed. It undergo an alpha and then followed by beta. So this new nucleus, which is X here example, 214 and 82, undergo a beta decay. In a beta decay, atomic mass does not change, but atomic number increases by 1. So atomic mass remains same, but atomic number increases by 1. So that is a beta emission. So alpha emission followed by beta emission, they're asking what is the nucleon number at the last, like what are the nucleon number and the proton number of a nuclide formed. So what is the nucleon number? That is 214. And what is the atomic number? That is 83 of proton number. So C is the right answer. Then in question 39, a scientist carries out an experiment using a sealed source which emit beta particles. The range of a beta particle in air is about 30 centimeter. Which precaution is the most effective to protect the scientist? Like beta particle can travel 30 centimeter in air. So scientists should be 30 centimeter or more than that. Like the distance between the scientists should be more with a source. So handling the source with a long tongue, that is right. Because if he's handling a source with a long tongue, means the source is away from him. So it will reduce the, like it will have a better precaution, like he's having a correct precautionary measure. So this radioactive radiation will not affect. Keeping a temperature of a source low, temperature pressure does not affect the amount of radiation from a radioactive source, because this radioactivity is a random process and it is spontaneous. It does not depend on the condition. Opening all the windows in the lab, that will increase the ventilation, but that is not reducing the effect from the source. And washing his hand before leaving the lab, that should be done, but that is not like minimizing the exposure to the source. So A is the right answer, that he will be minimized, like using a long tongs. So it will reduce the chance that a person will be affected by the radiation. In question 40, which would describe the nature of alpha? Alpha particle are 2 proton and 2 neutron, which we also call helium nuclei, and gamma is the electromagnetic radiation. So A is the right answer. In this question, there is a radioactive source. The substance emits the radiation at a rate of 600 emissions every second. 4 hours later, it emits at a 300. What is the half-life of a substance and what is the rate after further 4? So basically, like it was 600 and 600 become 300. So it means it become half. So time it took, as I mentioned, it took 4 hours. So time it took to be half of its original, that is known as the half-life. So what is the half-life? The half-life is actually 4 hours. Because after 4 hours, it become half of its original value. Originally it was 600, now it become 300. And then they're asking what will be the radiation after further 4 hours. So means after another half-life, what will be the amount? It will be half of this. So it is 300. So 300 will become 150. So the half-life is 4 hours and the amount after further 4 hours, that is 150. So 4 and 150, D will be the right answer. So it won't be 0. It will be according to half of the original value. So in question 38, a nuclide notation of a silver, how many nucleons? Nucleon number, this is a nucleon number. So how many nucleons are there? 109. The equation represent a radium decay into radon. So atomic mass decreased by 4 and atomic number decreases by 2. So which particle is this? That is alpha. And what is alpha particle? Alpha particle is known, this is a symbol, or we also called a helium nuclei. Because helium contains 2 proton and 2 neutron, the nucleus of helium, and alpha also 2 proton and 2 neutron. So which symbol should be there? It's an alpha particle or helium nuclei. So C is the right answer. Then in question 40, the atomic nucleus decay by one or more radioactive decay processes. What cause a proton number decreases by 1? So look, if in alpha decay followed by beta decay, if alpha decay is there, if there is an alpha decay, it will first decrease by 2 because of alpha decay, atomic proton number decrease by 2. And when it is a beta decay, it increases by 1. So what is the overall change in a proton number or a atomic number? Due to alpha decay, it decreases by 2, and due to beta, it increases. So what is the overall change? It will be -1. So it will decrease by 1. If there was only alpha decay, what will happen if there was only alpha decay? So it will decrease by 2. If it is a beta decay followed by gamma, in beta decay, it increases by 1, and gamma, there is no change. So it will remain +1, like in overall increase by 1. If beta decay only, so it also increases by 1. So always remember, when there's an alpha decay, nucleon number decreases by 4 and atomic number or proton number decreases by 2. If it's a beta decay, nucleon number, no change, it remains same, and atomic number or proton number increases by 1. And if it's a gamma, then there is no change in nucleon number and no change in proton number.